So we're going to finish 4.9. Just as a side note, I still would like to make exam 3. We're running out of time. So if I do make the test, it'll be this Thursday or Friday for quiz 3. Let's make that a plan. I can always cancel it if it doesn't work out, but the plan is to post the quiz on the 29th. And have it due a week later on the 6th. And that way, during the last week of instruction, we won't have any assignments, and then during finals week, we'll take the final, which is basically exam 3. I want to do quiz 3 because there are they're pretty good topics we've covered that I have questions for, which would be increasing, decreasing, maxes, mins, concave up, concave down, and L'Hopital's rule. Okay, so for those topics, I would like to have some quiz questions. We'll see. I need to grade quiz 2, and I would like to finally do the grade book for Canvas. So let's just do notes today. Cool. So first, all right. Definition of definition of a differential equation. So it is an equation that has derivatives in it. All right, so these are also DE for differential equation. Okay, so I have steps for solving for the original function when you're given a differential equation. To find a particular solution. Let's just go like that. A particular solution to a differential that satisfies a differential equation. DE is differential equation and initial conditions. A, find the general solution, or in this case, general antiderivative. Okay, to get the particular solution, apply initial conditions, and then that will give you the function that you're looking for. I think that's it. Sometimes you need to repeat these steps to get that particular solution that you were asked to find. And also, when you apply those initial conditions, you're solving for the constant C. Okay, so first one, find the function f if f prime of x. So let's get started. Find f. If f prime of x is 2x minus sine of x. And the initial condition is f of 0 equals 3. Okay, so you have this differential equation. It's got a derivative in it. And you have this initial condition. So first we're going to get the general solution by finding the antiderivative of f prime of x. We'll apply that initial condition, and that will be f, our function, the original function. Cool. Part A. The antiderivative of f prime of x is f of x. Okay, let's get this. So we talked about antiderivatives last time, and we still need to do more practice, but this will give us some practice. So you have a constant, which stays. Derivative of x is antiderivative. So we're going reverse. You add to the power and divide by that number. X squared over 2. The antiderivative of sine is negative cosine. So we have a minus negative cosine plus cosine x plus c. And this time we can just put plus c. There's only one constant. There's only one antiderivative that I'm going to do. Okay, apply initial conditions. For the function f, it's this part here. It's when f sends 0 to 3. F of 0 will be 3. Cool. So this is our general function, our general solution, and we're putting in x equal to 0. So send in a 0 through here. of 0 would be 2. Let's see, 2 over 2 reduces to 1, so I've got x squared as my first term. Add cosine of 0. Add c. And we're trying to solve for c. So replace f of 0 with the info you have. F of 0 is 3. So I want 3 sitting here and copy this side down on the other. Let's copy it first. 0 squared is 0. Add cosine of 0, which is 1. Add c. F of 0 is being replaced with 3. Okay, so let's do minus 1, minus 1, got 2 equals c. So use that to write your final function. F of x is x squared plus cosine x plus 2. Okay, and this would be your general solution, or this is your function f. And what we've done is, actually, we had the general solution with plus c. This is a particular solution when you have found c. Okay. Also, let's just maybe show that this is my answer, and I like to put a square. Sweet, we did one. The next one's a little harder, but you have a differential equation and initial conditions, and you have to find the function f. So I think we're ready. Starting with a new problem. Find the original function f if f double prime of x equals 3 plus e to the x minus cosine x. And see, f prime of 0 equals 1. And f of 0 equals 2. And then that's all the info you get, which we're going to point out that's your differential equation. It's a function, or it's an equation that contains derivatives. This is an initial condition, and this is an initial condition. And you want to find f, but you're given f double prime. So take f double prime, get an antiderivative of f prime, and then get the antiderivative again to get to f. So just big picture, you're going to have f double prime, and then find f prime, and then find f. So we're going to do steps A, B. We're going to do steps A, B again, and then we'll be done. Okay, so first, part A would be find the general antiderivative of f double prime, which is f prime. Okay, so the antiderivative of 3 is 3x. You can check by going from here to here, take the derivative of 3x, gets you here to 3. Okay. Antiderivative of e to the x is e to the x. The antiderivative of cosine is sine. And then add c. But we're going to do an antiderivative twice, so this will be the first constant called c1. That's right. F prime of x is 3x add e to the x minus sine x minus c sub 1. Okay, we want to find that constant. So use your initial conditions. The one that has information for your f prime. F prime of 0 is 1. So you're first letting x equal 0 in that function, f prime. 3 times 0, 0, sine 0, add c sub 1. Okay, from here to here, on this side of the equal sign, we'll simplify. This is 0, this is 1, this is 0. F prime of 0 equals 1. So this is being replaced. Okay, 1 equals 1 plus c1. Minus 1 on each side. C sub 1 equal to 0. Okay, so the particular solution for f prime of x would be f prime of x equal to 3x add e to the x, subtract sine of x plus 0. All right, so we repeat these steps to get f. Okay, find the general antiderivative of f prime, which is f of x. So you have your constant 3, just stays where it is. Take the antiderivative of x. So right here, we have x. Add 1 to the power, divide by that number. X squared over 2. Antiderivative of e to the x is e to the x. Minus the antiderivative of sine, which should be a negative cosine of x. So we're going to add cosine of x. Add some constant we're going to call c sub 2. Okay, now we need to know what c sub 2 is, and you use your initial conditions, which is part B. Here's the info for your function f. F takes 0 to 2. F of 0 equals 2. Okay, so first put 0 through the function that you found, or that we have found. 3 over 2 times 0 squared. Add e to the 0. Add cosine of 0. Add c sub 2. Okay, f of 0, we're going to substitute this part here. F of 0 equals 2. I'm going to replace this guy with 2. This side, just simplify. 0 times any number is 0. Add a number to the power 0 is always 1. Cosine of 0 is 1. And c sub 2 at the end. Okay. 2 equal to 2 plus c2. Minus 2, I got a 0 equal to c2. Right, we finally reached the function f of x. With c sub 2 equal to 0 would be 3/2 x squared. Add e to the x. Add cosine of x. And then there's a plus 0 at the end, which we don't need to write. So when you don't know what the constant is, it's called the general solution. When you find that constant, when you have an actual number value for it, it's a particular solution. Okay. So I have a reminder. In the past, we had s of t as a position function. S prime of t is your velocity function, v of t. And s double prime of t is acceleration function, a of t. So I have two problems where we get the antiderivative, like we go from a of t and find v of t, or something like knowing your velocity function and then finding your position function using that antiderivative. Okay, first one. A particle moves with the following acceleration. So particle moves acceleration, which we call a of t equal to, let's see, this is a whole function. A of t is equal to e to the t minus sine of t. And it has an initial velocity of 2 meters per second. Cool. And initial position of 5 meters. Okay, so find the position function, and that's it. Find S of t. Okay, so if you have your acceleration function, we can get an antiderivative, which will get us to the velocity function. Antiderivative, again, will get us to that position function. So we're going to have to repeat steps A and B. Just do A and B, and then do it again. Before we go through the steps, let's list out all initial conditions. So again, this would be part of my scratch work. Initial conditions. Okay, your initial time is when time equals 0. Okay. Initial velocity of 2 meters per second. So that would be v of 0. So the velocity at time 0. And that is here, blah, 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 velocity of 2. Okay, initial position, so that's your S function, position function, and it's at its initial position when t equals 0. Okay, and the initial position is 5. Okay, my initial conditions. Good. Find S double prime, use S double prime of t to find S prime of t. Okay, I want let's first rewrite what the acceleration function was. Acceleration is S double prime of t. And it was e to the t minus sine t. Okay, and the antiderivative is S prime of t. Which we call v of t. Antiderivative of e to the t is e to the t. Minus sine, we just copy. The antiderivative of sine would be negative cosine. So we're going to add cosine of t. And then we add some constant c sub 1. So That's one general solution for s prime of t. Let's find the particular solution for s prime of t. Which we call part B. We have s prime of 0 equal to 2. So put 0 for x into the s prime of t function that you found. 0 for t. So 0 for t is an e to the 0. Add cosine of 0. Add c sub 1. Okay, s prime of 0 replaced with that number, 2. This side we just simplify. E to power 0 is 1. Cosine of 0 is 1. And then plus c sub 1. All right, and solve for c sub 1. Zero. So our function s prime of t is e to the t plus cosine of t plus 0. Okay. We need to repeat this because we've only gotten to s prime of t, and we want to do another antiderivative to get to s of t. All right, I got this. We have s prime. Let's write it again. S prime of t is e to the t plus cosine t. Get the antiderivative s of t. Take this antiderivative, which is e to the t, copy down your plus sign. Antiderivative of cosine should be sine of x. Make sure here, let's see. A little behind my notes. This here we got solve for c sub 1. Have that function. Sine of t and add c sub 2. Some constant. Apply the initial condition, one of them. Use s of 0, and that was equal to 5. So first let t equal 0 in this function right here. E to the 0 plus sine 0 plus c sub 2. Cool. And in this next step, on this side, substitute s of 0. We're told that s of 0 is 5. On this side, we just simplify. E to power 0 is 1 plus sine of 0, which was 0, plus c sub 2. So we're going to minus 1 from both sides and get c sub 2 equal to 4. Okay, so we put everything together. We finally got the position function s of t. S of t is e to the t plus sine of t plus c sub 2, which equals 4. Cool. Where are we? All right, we have 8 minutes, so I can at least set up this problem and we'll just finish it next time, and then we'll be done with chapter 4. I'm so excited. Okay, so we're gonna start with talking about gravity. Actually, before we even do that, we're talking about objects in free fall. So they're going to be affected by gravity, since we're going to be close to the surface of the Earth. Okay, so gravity is a constant, and it's constant acceleration. All right. Usually we will use, like in the US, the standard is to measure with feet. So we're going to use negative 32 feet per second squared. A of t, my acceleration function, is a constant of negative 32 feet per second squared. Okay, but in other places, if you use meters, it's kind of like a metric measurement. So we'll put metric. And your acceleration function, A of t, would be negative 9.8 meters per second squared. Okay, so again, we're mostly going to use this one, but just check what your units are in your function. Cool. Let's do as much of this problem as we can until the timer goes. So a rock is thrown off a cliff that is 350 feet tall. Okay, so if they're measuring in, let's see, we're going to do feet, 350 feet. Cool. And it's with initial velocity of 10 feet per second. Word problems used to really intimidate me, but after practicing, especially these types of problems, I've gotten much more comfortable. It really helps to draw a picture, which we're going to do next. Initial velocity. Of 10 feet per second. Find the position function S of t. And we're going to call this part A. Part B is to find how long it takes for the rock to hit the ground. And we'll do that later. Let's draw a picture. So over here, we have the ground. And this is going to be values of, we're going to have this represent values for time, t. Okay, from here, let's draw a little cliff. So that's the top of the cliff, and we have a person at the top. And they have a rock, and they're going to throw the rock with velocity. So it's going to come up and down. And right there, it hits the ground. So part A, we're just going to get a position function that shows you where you are, where the rock is for any value of t. And then this t value right here, we'll do in part B. That's when the rock hits the ground. Okay, so we actually just assume that there's an acceleration because there's going to be gravity. So we're going to use, first thought is make sure that you use your acceleration function that has the units in feet. Okay, so this is just units on the side. -32 for acceleration of t. And then we're going to find v of t. After that, we'll use v of t to find s of t, which is the goal. So again, I'll try a big picture of like what the scratch work looks like. We have a of t. We'll use the antiderivative and initial conditions to get v of t. For v of t, we'll take an antiderivative, apply initial conditions, and get s of t. And then we'll be done, because that's what we want. So first, antiderivative. Well, I'm just going to write down the differential equation that we have for sure. We're out of time. Let's finish just this last thought. Okay, a of t is -32. So v, which is, okay, a of t is v double prime of t, which is -32. V prime of t is the antiderivative of a of t. Make sure. Maybe we should just call it and come back later. All right, actually, we've at least written the problem down. We drew a picture. We'll come back and actually start with writing all initial conditions and getting our first antiderivative, which is starting to become too short on time today. Okay, thank you for being at this meeting.